A largely unsung hero in the fight against COVID-19 was that weirdo amino acid we like to call proline. So what am I talking about? The amino acid proline is a weirdo because unlike the other amino acids protein building blocks that kind of have their side chains, their unique parts wave around, proline actually wraps around on itself. And this constricts the proline and the region around the proline so that it can't move very much. So it acts as a kind of stiffener. Now, in the coronavirus spike protein, so that protein that sticks out from the coronavirus's membrane and that latches on to host cells and then draws itself in, that protein is the target for vaccines. And scientists knew when COVID came on the scenes that if they wanted to make a vaccine that is going to allow the immune system to recognize and attack this virus before it could get into our cells, that would be a great target, because if they could prevent the spike protein from docking onto receptors on our cells, then they could prevent the virus from getting into our cells. And so antibodies could then go and block the binding, and then that would make it so that the virus can't get in. But in order to help design the antibodies, in order to help design vaccines, they need to get a look at this protein. They need to get the protein, a form of this protein that is stable enough to survive, to allow the immune system to recognize it. And what am I talking about with stability and stuff? Well, if we think about the spike protein, it's kind of like this. It's hard to do with my hands and stuff, but it's a homotrimer, so there's 3 copies, so I only have 2 arms, but so just imagine there's a third one of these. And then you have this receptor binding domain that's going to go up and down and up and down and up and down. That's what's actually going to bind to the receptors on the host cells. And what happens is that upon binding, you actually undergo this shape change, this conformational change, that's really dramatic. So you go from this prefusion state, before it's kind of fused with the host, to the post-fusion state. And so if you think about kind of like my wrists, it goes like this, so prefusion, post-fusion, prefusion, post-fusion. You want the immune system to be able to recognize that prefusion state, but the virus can sometimes spontaneously go into that post-fusion state. And that would make it so then it's going to be hiding the region that you want the immune system to recognize. By engineering proline so that it stiffens those regions, now you can make it so that you have a form that is more stable enough that scientists could get a structure of this protein very early on, and that they could then use this version with these 2 prolines in the design of the vaccines, and that allows it to be stable enough for the immune system to recognize. In addition to proline, we have Jason McClellan to thank, because he knew where to put the prolines thanks to his work on RSV previously.